Imagine a future where energy flows from the heavens. Picture a world where the vast expanse of space is not just a frontier for exploration, but a source of endless, clean energy. This isn't just a dream, it's a vision that scientists and engineers are working tirelessly to bring to life. A future powered by the sun, day and night. Imagine solar panels that never sleep, capturing the sun's energy even when it's night on Earth. This continuous energy supply could revolutionize how we think about power, making energy shortages a thing of the past. This is the promise of space-based solar power. By placing solar panels in space, we can harness the sun's energy more efficiently than ever before. These panels would be free from the limitations of weather and the day-night cycle, providing a constant stream of energy. China, a nation known for its ambition, is taking on this challenge. With its rapid advancements in space technology, China is positioning itself as a leader in the race to develop space-based solar power. Their scientists and engineers are working on groundbreaking projects that could change the energy landscape forever. They aim to build a power station in space. This isn't just a small-scale experiment, it's a massive undertaking that involves constructing a fully functional power station in orbit. The scale of this project is unprecedented, requiring new technologies and innovative engineering solutions. This station will capture the sun's energy. Positioned high above the Earth, it will have an unobstructed view of the sun, allowing it to collect solar energy more efficiently than any ground-based system. This energy will then be converted into electricity and prepared for transmission back to Earth. It will then send this energy back to Earth. Using advanced technology, the captured solar energy will be beamed down to receiving stations on the ground. This method of energy transmission is still in development, but it holds the promise of delivering vast amounts of power with minimal loss. The goal? To generate a staggering 100 billion kilowatt-hours of electricity. This amount of energy could power millions of homes and businesses, significantly reducing our reliance on fossil fuels and helping to combat climate change. This power will come from a point 36,000 kilometers above Earth. At this altitude, the solar panels will be in a geostationary orbit, meaning they will remain in a fixed position relative to the Earth, ensuring a constant supply of solar energy. This is not science fiction. The technology to make this vision a reality is being developed right now. Engineers and scientists are working on the challenges of space construction, energy capture, and transmission, turning what once seemed like a distant dream into a feasible project. This is a bold vision of the future. It's a vision that requires innovation, determination, and global cooperation. If successful, it could transform our energy systems and pave the way for a sustainable future. It is a future where clean energy is abundant. A future where we can harness the power of the sun not just from our rooftops, but from the vast reaches of space. This is the promise of space-based solar power, a promise that could change the world. Why build a power station in space? The answer is simple. The sun's energy is incredibly powerful. In space, there's no atmosphere to block this energy. There are no clouds to get in the way. It's a constant, reliable source of power. China's vision is ambitious. They plan to build a solar array that's 1 kilometer wide. This massive structure will be made up of thousands of mirrors. These mirrors will focus sunlight onto a central point. This concentrated sunlight will then be converted into electricity. This is a daring endeavor, pushing the boundaries of what's possible. The solar array will be strategically positioned in space. It will orbit Earth at a specific distance. This will allow it to receive sunlight almost continuously. The mirrors will track the sun's movement. This ensures that the sunlight is always focused on the central point. This constant stream of sunlight is the key to space-based solar power. It means that the power station can generate electricity 24 hours a day. It doesn't matter if it's cloudy on Earth. It doesn't matter if it's night. The power station keeps working, tirelessly beaming energy back home. Once the electricity is generated, it needs to be sent back to Earth. This is where things get really interesting. China plans to use microwaves to transmit the power. These microwaves will be beamed from the space station to a receiving station on the ground. Microwaves might sound dangerous, but they're not. They're a safe and efficient way to transmit energy wirelessly. They can travel through clouds and rain without losing much energy. This makes them ideal for beaming power from space. Section 5. Building a power station in space. Building a power station in space is no easy task. It requires cutting-edge technology and incredible engineering. China is developing new rockets and spacecraft specifically for this project. One of the key components is the Long March 9 rocket. This powerful rocket will be used to transport materials and equipment into space. China is also building a dedicated facility in Chongqing. This facility will be used to assemble and test the solar power station before it's launched into orbit. The construction process will be complex and challenging. However, China is determined to make this vision a reality. Section 6. A new dawn for energy? The potential impact of China's space solar power project is enormous. Imagine a future where energy is harvested directly from space, bypassing the limitations of terrestrial solar panels. This ambitious project aims to capture solar energy in space and beam it back to Earth, providing a constant and reliable source of power. The station is expected to generate enough electricity to power millions of homes. This means entire cities could be powered by clean, renewable energy, reducing the strain on our planet's resources. The energy harvested from space could light up our homes, power our industries, and drive our electric vehicles, all while reducing our carbon footprint. This could significantly reduce China's reliance on fossil fuels. Currently, fossil fuels are a major source of pollution and greenhouse gases. By shifting to space-based solar power, China could cut down on emissions, leading to cleaner air and a healthier environment. This transition could also inspire other nations to follow suit, accelerating the global shift towards renewable energy. It could also pave the way for a cleaner and more sustainable future. The success of this project could lead to advancements in other renewable energy technologies, making them more efficient and accessible. Imagine a world where clean energy is the norm, and our reliance on harmful fossil fuels is a thing of the past. To put the energy output into perspective, it's helpful to compare it to existing power plants. Traditional power plants, whether coal, nuclear, or hydroelectric, have limitations in terms of location, resource availability, and environmental impact. Space-based solar power stations, on the other hand, have the potential to overcome these limitations. The Three Gorges Dam, the world's largest hydroelectric power station, generates around 100 billion kilowatt-hours per year. This is a staggering amount of energy, but it also comes with significant environmental and social costs. The construction of the dam displaced millions of people and altered ecosystems. China's space power station aims to match that output. By harnessing the power of the sun in space, this project could generate a similar amount of energy without the same environmental and social impacts. This innovative approach could revolutionize the way we think about energy production. This highlights the immense scale and potential of this project. The successful implementation of space-based solar power could mark the beginning of a new era in energy production, one that is sustainable, efficient, and environmentally friendly. As we look to the future, projects like this give us hope for a cleaner, greener planet. Section 7. The challenges ahead. While the potential benefits are immense, there are also significant challenges. One concern is the safety of microwave transmission. While microwaves are generally safe, it's crucial to ensure that the beams are focused and controlled. This will prevent any potential harm to humans or wildlife. Another challenge is the issue of space debris. There's already a lot of debris orbiting Earth. It's important to ensure that the space power station doesn't contribute to this problem. China is developing strategies to mitigate space debris. These strategies include designing the station for easy deorbiting at the end of its life. Section 8. A global endeavor. Addressing these challenges requires international cooperation. Space exploration is not a solitary endeavor. It requires collaboration and shared knowledge. China has expressed its willingness to work with other countries on this project. This collaboration is essential for ensuring the safety and sustainability of space-based solar power. It's also important to remember that this technology is still in its early stages. There are many technical hurdles to overcome. Continuous investment in research and development is crucial. This will lead to breakthroughs in areas like energy conversion, wireless power transmission, and space construction. Section 9. A giant leap for humanity? This is a question that has intrigued and inspired generations. The idea of harnessing the vast untapped energy of space has long been a dream of scientists and visionaries alike. China's space solar power project is a bold and ambitious endeavor. It aims to capture solar energy directly from space and beam it back to Earth, providing a constant and inexhaustible source of clean energy. This project is not just about technological advancement. It represents a significant leap in our quest for sustainable energy solutions. It has the potential to revolutionize the way we generate and consume energy. Imagine a world where energy is abundant and accessible to all, where the limitations of terrestrial solar power, such as weather and daylight hours, are no longer a concern. This could lead to a dramatic reduction in our reliance on fossil fuels and a significant decrease in greenhouse gas emissions. It could be a game changer in the fight against climate change. The ability to harness solar power from space could provide a reliable and continuous source of energy, helping to mitigate the effects of global warming and environmental degradation. This technology could transform polluted cities into clean, green urban centers and slow the melting of glaciers by reducing our carbon footprint. However, it also presents significant challenges that require global cooperation and technological innovation. The development and deployment of space-based solar power systems will necessitate unprecedented levels of international collaboration. Scientists, engineers, and policymakers from around the world will need to work together to overcome technical hurdles and ensure the safe and efficient transmission of energy from space to Earth. As we look to the future, the question remains, are we ready to embrace this new frontier of energy production? Are we prepared to invest in the research and development needed to make space solar power a reality? The potential benefits are immense, but so are the challenges. It will require a collective effort and a shared vision of a sustainable future. Are we willing to invest in the technologies and partnerships needed to make this vision a reality? The success of this endeavor will depend on our ability to forge strong partnerships between governments, private companies, and international organizations. It will require significant financial investment, as well as a commitment to long-term planning and innovation. The answers to these questions will shape the future of energy, sustainability, and our place in the cosmos. As we stand on the brink of this new era, we must consider the broader implications of our actions. The choices we make today will determine the legacy we leave for future generations and our role in the ongoing exploration of space. The journey ahead is challenging, but the potential rewards are beyond measure.